Hi everyone, and welcome to this video. Today, we're taking a closer look at Halpe Estate Rubber Factory, one of the plantations in Sri Lanka that processes natural rubber. This factory takes raw latex collected from rubber trees and turns it into different rubber products used in everyday life. For a quick overview, natural rubber is a polymer obtained from the sap of rubber trees. It's flexible, strong, and used in many products, like tires, mats, gloves, and even industrial equipment. In this video, we'll follow the entire journey of rubber in the factory. From tapping the trees, collecting latex, adding chemicals, coagulating and rolling, drying, grading, packaging, and even how secondary products and wastewater are managed. So, let's dive in and see how raw latex becomes high-quality rubber ready for use.
Tapping and latex collection.
Now, let me explain the first step in natural rubber production, which is tapping and latex collection. Before tapping begins, it is very important to select a suitable rubber tree. Only mature rubber trees are used for tapping. Generally, a rubber tree becomes suitable for tapping after about 6 years of growth. At this stage, the tree should have a girth of about 50 centimeters, measured at a height of around 1.20 meters from the ground. This ensures that the tree is strong enough to produce latex without being damaged. After selecting the tree, the correct tapping panel is chosen. First, a vertical straight line is drawn on the front side of the tree. This line is called the nethi kanu. Then, from the opposite side of the tree, another vertical straight line is drawn, at about half of the tree's diameter away. This is called the poi kanu. After that, an aluminium stencil is placed on the tree, and the tapping marks are drawn accurately. This helps to maintain the correct shape, length, and position of the tapping cut. Usually, tapping is done on one side of the tree for about 6 months, and then the tapping panel is changed to the other side to allow proper healing and rest. Next comes the initial tapping cut. A slanted cut is made on the bark using a special tapping knife. The cut is made at an angle of about 30 degrees to the horizontal. This angle helps the latex to flow down smoothly into the collection cup. The cut must be done very carefully. Only the outer bark should be removed. The cut should stop about 1 millimeter away from the xylem so that the cambium layer is not damaged. Protecting this layer is extremely important for the long-term productivity of the rubber tree. Latex flows through special channels called latex grooves, also known as polycanals. These grooves guide the latex down into a collection cup fixed at the base of the cut. Proper alignment of these grooves helps to prevent latex loss and contamination. The tapping interval is another important factor. Rubber trees are not tapped every day. Usually, tapping is done once every 2 or 3 days, depending on the tapping system used. This resting period allows the tree to regenerate latex naturally. The time of tapping also plays a major role. Tapping is normally carried out early in the morning, usually between 4:30 a.m. and 7 a.m. During this time, the temperature is low and latex flow is higher, which improves both yield and quality. Once the latex is collected in the cups, it is transferred into larger containers and then transported to the factory for further processing.
After the latex is collected from the rubber trees, the next step involves purchasing and inspecting the latex before it enters the factory for processing. Rubber tapping laborers, also known as tappers, collect the latex in cups attached to the trees. The collected latex is then brought to the buying center, where it is measured and purchased by the factory or by middlemen. However, the payment is not based only on volume. Instead, tappers are paid according to the DRC, or dry rubber content, which represents the actual amount of rubber present in the latex. To measure this, a small sample of latex is taken first. From the collected latex, 33 milliliters of latex is measured, and then 66 milliliters of water is added to it. This diluted sample is mixed well. After that, a metrolac instrument is placed into the mixture to measure the density. The metrolac floats in the liquid and the reading is taken from the scale. Next, this density value is checked using a datasheet provided at the buying center. According to this chart, the measured density is multiplied by 30 to calculate the DRC weight of the latex. This DRC weight is the value used to decide the payment to the tappers, because it shows the real amount of usable rubber in the latex, not just the water content. Once the latex is purchased and approved, further quality assessment continues. Density gives a good indication of the rubber content in the latex. Latex with higher rubber content is more valuable and produces better final products. If the density and DRC are within the acceptable range, the latex is approved for processing. If the value is too low, it may be considered low-grade or diluted. This step is closely related to the tapping and collection process, because the care taken during tapping, such as using the correct cutting angle, tapping at the right time, and avoiding contamination, directly affects the latex quality. Latex that is handled carefully flows better, has higher rubber content, and passes the density and DRC checks more easily. In this way, purchasing, measuring, and quality testing ensure that the latex entering the factory is suitable for coagulation and further processing.
Use of chemicals.
After collecting the latex and checking its quality, the next step is adding a few important chemicals. These chemicals help to protect the latex and prepare it for the next stages of processing. First, let's talk about Nexo bleach, new formula, water-soluble. This chemical is mainly used to control bacterial growth in latex. Since latex is a natural material, it can spoil very easily if bacteria grow inside it. Nexo bleach helps to keep the latex fresh and prevents bad smells or early spoilage. Because it is water-soluble, it mixes well with latex and does not affect its natural flow. Next, we use formic acid 85%. This is a very important chemical in rubber processing. Formic acid is added when we want the latex to coagulate, or in simple terms, to turn from a liquid into solid rubber. When the correct amount of formic acid is added, the rubber particles come together smoothly and form good quality rubber sheets. The concentration is carefully controlled so that the rubber does not become too hard or damaged.
Coagulation.
After purchasing the latex and adding the required chemicals, the next major step in the rubber processing line is the coagulation process. First, the purchased field latex is collected into a large mixing tank at the factory. This tank is used to combine latex received from different tappers so that a uniform mixture can be obtained. Once the latex is inside the large tank, it is thoroughly stirred using mechanical paddles. This mixing step is very important because it helps to distribute the latex evenly and ensures that the rubber content is consistent throughout the tank. Proper mixing also removes air bubbles and prevents uneven coagulation later. After mixing, the required chemical is added. In this stage, formic acid is slowly introduced into the latex. The amount of acid added is carefully controlled to avoid overcoagulation. As the acid mixes with the latex, the rubber particles begin to come together and the coagulation process starts. Once the latex reaches the correct condition, it is then transferred from the large tank into smaller coagulation tanks. Dividing the latex into smaller tanks allows coagulation to occur more evenly and efficiently. It also makes the handling of rubber slabs easier in the next stages. Inside these smaller tanks, the latex is left undisturbed for a certain period of time. During this time, the liquid latex gradually turns into solid rubber slabs, while the serum separates out.
Milling and rolling process.
After the coagulation process is finished, the solid rubber slabs are taken out of the tanks and moved to the next important stage, which is milling and rolling. This step is mainly used to clean the rubber, shape it, and improve its quality before it goes for drying. First, the rubber slabs are fed into milling machines with two heavy rotating rollers. As the rubber passes between them, strong pressure is applied. This pressure helps to squeeze out extra water, remove dirt and impurities, and soften the rubber, making it easier to work with. As the rubber goes through the rollers again and again, it becomes thinner, wider, and more even, and its texture and flexibility improve, which makes it suitable for forming into sheets. At the beginning, the rubber is processed using grooved rollers, also known as creeping or washing rollers, with continuous water spray. The rubber entering this stage is still thick, rough, and full of serum and acids from the coagulation process. The main purpose here is to wash and clean the rubber properly while shaping it into sheets. In the first pass, the thick slabs are roughly flattened. A lot of trapped water and serum is squeezed out, and the rubber becomes wider and thinner, though it is still quite rough. In the second and third passes, the same sheet goes through the grooved rollers again with plenty of water. The grooves help to knead the rubber, and the water helps to wash out more dirt, acids, and serum. By this stage, the rubber is much cleaner, softer, and more uniform, even though the surface is still ribbed. By the fourth and fifth passes, almost all of the remaining serum has been washed away. The repeated pressing and washing make the rubber smoother, more uniform and more flexible, and we now get a well-cleaned, evenly crept sheet that is ready for finishing. Throughout this whole process, the water spray plays a key role. It prevents the rubber from sticking to the rollers, helps to wash away remaining impurities, and also controls the temperature, protecting the rubber from heat damage. Once the rubber is properly cleaned and prepared, it is passed through smooth rollers, also known as finishing or sheeting rollers. Here, the purpose is no longer washing, but giving the rubber its final shape and thickness. The rollers are set closer together, and the sheet comes out smooth, even and neat, ready for the next step, which is usually drying or smoking. The pressure of the rollers has to be controlled very carefully. If it is too high, the rubber can be damaged. If it is too low, the rubber will not be cleaned or shaped properly. That is why skilled workers adjust the machines to get clean, smooth, high-quality rubber sheets. So, in simple terms, about 5 passes through the grooved rollers with good water spray are usually enough to clean the rubber and prepare it for the smooth rollers. This milling and rolling stage is a very important step because it strongly affects the cleanliness, quality, and final performance of natural rubber before it goes to drying.
Drying process.
After the milling and rolling process, the rubber sheets still contain a significant amount of moisture. So the next important step is the drying process, which helps to remove this moisture and improve the durability of the rubber. At Halpe Estate Rubber factory, drying is mainly carried out using controlled heat. The ideal drying temperature is usually maintained between 45 degrees Celsius and 60 degrees Celsius. This temperature range is carefully selected because it is high enough to remove moisture but low enough to avoid damaging the rubber structure. The heat required for drying is produced by burning firewood. The heat generated from wood combustion is transferred through a radiator-based heating system. This system distributes warm air evenly throughout the drying chamber, ensuring uniform drying of rubber sheets without direct exposure to flames. Before drying begins, the rolled rubber sheets are arranged inside the drying chamber. The sheets are hung or placed in an orderly manner, starting from the upper level and moving downwards to the lower levels. A proper spacing is maintained between each sheet, allowing hot air to circulate freely around them. This vertical arrangement creates a time gap between the drying of upper and lower layers. Rubber sheets placed at the top receive heat earlier, while those at lower levels dry gradually. This controlled arrangement helps prevent uneven drying and improves the overall quality of the rubber. The drying process takes several hours to several days, depending on sheet thickness and moisture content. Once drying is completed, the rubber sheets become stronger, more stable, and suitable for long-term storage. This step is crucial because proper drying directly affects the color, strength, and shelf life of the final rubber product.
Grading and packing.
After the drying process is completed, the rubber sheets are ready for the inspection, grading and packaging stage, which is the final step before the rubber is sent to the market or for further industrial use. At this stage, every single sheet is carefully inspected to make sure it meets quality and cleanliness standards. The sheets are checked for dirt, impurities, color, thickness, and physical defects such as bubbles, stains, or uneven surfaces. Any contaminated or defective portions are cut and removed to maintain high-quality standards. Based on these observations, the rubber sheets are graded according to standard quality levels. High-grade sheets are clean, evenly colored, and free from visible defects, while lower-grade sheets may have minor imperfections, but are still suitable for secondary applications. Once grading is completed, the sheets are sorted and stacked according to their grade to maintain consistency. After that, the clean sheets are bundled into 25 kilogram packages. Each bundle is then passed through a 2-roll grooved mill, and this process is repeated 3 times to ensure the sheets achieve a uniform thickness and a smooth, reliable surface. Next, the processed sheets are measured and cut into smaller pieces. This cutting is done very precisely, with only a minimal amount of waste. This step also helps to prevent deformation of the sheets and keeps their quality consistent. After cutting, the rubber pieces are carefully packed into polyethylene bags. These packs are then compressed using a manual pressure machine. This compression makes the rubber easier to store and transport, reduces the space required, and at the same time protects the material from damage. During packaging, proper labeling is also done. Important details such as the grade, weight, production date, and factory information are clearly marked on each package. This makes handling, storage, and transportation much easier and more organized. Finally, the compressed and packed rubber sheets are ready for the market. From drying and inspection to grading, cutting and packaging, every step is carefully controlled to ensure that the crepe rubber sheets maintain consistent quality, durability and reliability and are delivered to customers in excellent condition.
Secondary products.
After grading and packaging, not all rubber sheets are classified as high quality. Some sheets may have minor defects in color, texture, or cleanliness. Instead of discarding this rubber, it is used to produce secondary rubber products. Lower grade rubber is collected separately and processed further. This rubber is still useful, even though it does not meet premium quality standards. It is commonly used in products where appearance is not critical, but strength and durability are still required. One important application of this lower quality rubber is in autopalu, or rubber-based mats and flooring materials. These products require strong and flexible rubber, but do not need a perfect surface finish. In addition, secondary rubber is used to produce rubber blocks, crepe rubber, industrial rubber sheets. By using lower-grade rubber for secondary products, the factory reduces waste and increases overall efficiency. This approach supports sustainable production and ensures that maximum value is obtained from natural rubber.
Cleaning wastewater.
After all the rubber processing steps are completed, the factory must handle the wastewater generated during production. This step is extremely important because it helps to protect the environment and nearby water sources. During rubber processing, water is used in several stages, especially during milling and rolling, cleaning of tanks and equipment, and coagulation and other chemical processes. Because of this, the wastewater contains latex residues, acids, and other chemicals, so it cannot be released directly into rivers, streams, or soil. At the Halpe Estate Rubber Factory, all wastewater is first collected into special treatment tanks. In these tanks, solid particles are allowed to settle, and the water is treated to remove rubber residues, acidity, and other impurities. One of the most important factors checked during this process is the pH value of the water. The pH is carefully adjusted to a safe range, usually between 6 and 8, so that the treated water becomes neutral and environmentally safe. In addition to pH, other quality checks such as turbidity, suspended solids, and chemical residues are also monitored to make sure the water meets environmental standards. According to regulations, this wastewater treatment unit must obtain an environmental license once every year. This license ensures that the factory is operating the treatment system properly and that the discharged water is safe for the environment. However, in practice, there is another important issue. Due to concerns and objections from nearby villagers, even when the wastewater is treated and neutralized to around pH 7, the factory is not allowed to release it into the nearby stream or waterway. Because of this situation, the factory now releases the treated water only into a pond located within the factory premises. So, instead of discharging it into natural water bodies, the treated wastewater is safely contained inside the factory area, reducing the risk of environmental pollution and avoiding conflicts with the local community. In this way, the wastewater management system at the factory plays a crucial role in protecting the environment, maintaining legal compliance, and ensuring that rubber production is carried out in a responsible and sustainable manner.
So, that brings us to the end of our overview of natural rubber processing at Halpe Estate Rubber Factory. In this video, we went through the full workflow: tapping and collecting, latex chemical treatment and coagulation, milling, rolling, and drying, grading, packaging, and making secondary products, cleaning wastewater, and managing the environment. Each step shows how careful, control, efficiency, and sustainability come together to produce high-quality rubber. A big thank you to the management and staff at Halpe Estate Rubber Factory for supporting this visit and allowing us to see the process up close. Thank you so much for watching, and I hope you enjoyed learning about the journey of natural rubber from the tree to the final product.